Got them. 64 and 65. Yes. Did I give you what that equals? Yeah, so see, you know it's not the same one. I was going to say we're going to have to split it up for sure. So if I make this pi over 4, 3 pi over 4, if I make it cosine x over sine x dx, what did you let be u? How'd you decide that it was sine? Because the derivative of sine is cosine. So I end up with 1 over u du. Now this is the point that I was trying to explain to you without writing it down. At this point, I could do the antiderivative, right? And then once I do the antiderivative, I could substitute u back out with sine x, and I wouldn't have to adjust the bounds. In other words, natural log of u. Determining the bounds, if I leave it as u, I'm going to have to adjust the bounds because u equals sine x, right? So if I leave it this way, I'm going to have to do sine of 3 pi over 4, which is, what's sine of 3 pi over 4? Square root 2 over 2. And then sine of pi over 4, same. But if I had done, if I said, well, it's the log of u, and I know that u is sine x, well, now I could use those original bounds. 3 pi over 4, pi over 4. At some point, you have to take into account the u, whether it's in the bounds or it's in the antiderivative, if that makes sense. Yes, you'd still plug those in. So you do the log of sine of 3 pi over 4 minus natural log of sine of pi over 4. Still come back to the same thing. Which other one did y'all say? 60? Ugh. From 0 to pi over 6, cosine to the negative third 2 theta, sine 2 theta. Oh, I think this is, I think this might be an identity. It might be an identity. What'd you let you be? And you chained it? Yeah. Yeah. We can do that. So we have, I need a 2 in here, right? So I need a 1/2 here. So I get 1/2 from 0 to pi over 6 u to the negative 3 du. Yes. Sorry. So negative 1/2. Oh, I need to adjust these bounds also. I prefer adjusting the bounds. What do y'all prefer doing? I would rather do that. All right, so this one's going to become cosine of 2 times pi over 6, which is cosine of pi over 3, which is 1/2. Yes. No, multiply it first and then find the cosine. This is just the cosine of 0, which is 1. Huh? Oh, yeah. All right, u to the negative 3 du. Antiderivative of u to the negative 3 would be negative 1/2 u to the negative 2 from 1 to 1/2. I'm going to kind of do this. Negative 1/2 times. Could have taken that negative 1/2 out also and made it 1/4. 1/2 to the negative 2 minus. No. Just plugging those bounds in because I've already adjusted them. Now we hope we don't make a careless computational mistake. Let's see, this would be negative 1/2 times, flip it and square it, 4, minus a negative would be plus 1/2. Negative 1/2 times, this would be negative 2 plus 1/2. Is that the right answer? Whew. It was all this that got all confusing. Which other one? The multiple choice? 63? 63, I think I will let you be t minus 3. So du would just be dt. So I end up with the integral of 1 over u, and I'm going to adjust my bounds here. So instead of 2, it'll be 2 minus 3 or negative 1. And instead of 1, it'll be 1 minus 3 or negative 2. So I'm going to have the natural log of u evaluated from negative 2 to negative 1. I can't do log of a negative number. So it's the absolute value. So I get log 1 minus log 2. Is that what I got? Log of 1/2. What number is this? 63. Log of 1 is 0, yeah. There you go. So dark outside. And the multiple choice. Which one? 73? Okay. Which one do y'all need me to do? So 74? I don't remember which ones you have. Alright, so from 0 to 2, e to the 2x dx. I think we should let u be 2x, which means du is 2 dx. So I need a 2, I need a 1/2. I have 1/2 times the integral of e to the u du, and I'm going to adjust those bounds. So it's just 2x, right? So this one would be 2 times 2, which is 4. 2 times 0, which is 0. 1/2 e to the 4th minus e to the 0. Well, anything to the 0 is 1, so I get 1/2 times e to the 4th minus 1. And let's see how the answers are written. I'm going with D. D is e to the 4th minus 1 over 2, which is the same thing. Multiplying everything by a half is the same as dividing everything by 2. Does that make sense? 75. Ooh. Ooh. Okay. Let me try to wrap my brain around this. The integral from 3 to 5, f of x minus a dx equals 7. Where a is a constant, then the integral, this is what it's asking, 3 minus a, 5 minus a of f of x in here, crickets in here. It would have to also equal 7. Because if you adjust, if you let u be x minus a, then du is dx, then this is just the integral of f of u du, and then if I adjust the bounds, I plug in here, I get 5 minus a, 3 minus a, and then if I substitute my u back in, it comes in, I'm still back to the same thing. So it's got to still equal 7. So the answer, is that what they got to? Because they've essentially adjusted the bounds for the u substitution is what they did. I think that was the point of that one. That was kind of Which other one? 76? Y'all don't like these slope fields. I've got practice for them, but I have to show you separation of variables first today because it's a mixed practice with that, so we might do that tomorrow. If the differential equation dy dx equals f of x leads to the slope field shown below, which of the following could be the integral of f of x dx? Well, let's see. it looks like well, which one of the graphs does it look like? Does it look like sine or cosine? What's the difference in the two? Which one goes where? Ooh. What's the graph of sine look like? What's the sine of 0? 0, right? So I'm trying to get the board to come back up. I'm sorry. All right, so the graph of sine goes through 0, 0. Now remember, this is a family of functions, right? So this is as they've been adjusted and slid and everything. But at the end of the day, the graph of sine looks like this because it goes through 0, 0, right? And the graph of cosine starts, what's the cosine of 0? 1, I just put it on there, sorry. So 0, 1 is on this graph, so it peaks there at the axis. So it does something like this, right? So this is cosine as opposed to sine. So it's easy, or I hope it's easy, to look at that picture and tell if you're looking at a sine graph or a cosine graph. Which one do you think you're looking at? A sine, right? See where it's peaking over to the right? Y'all see it? Are y'all okay? And then if it was negative, so now I'm wondering, is it sine x or is it negative sine x? Well, negative sine x is a reflection, right? So if I reflected this, it would be here. So look at the graph. Which one does it look like, the red or the blue? The blue. So it's got to be A. Does that make sense? All right. Tell me what you think about the U substitution. Yes, no, maybe so. Maybe so. Do we need practice with the U substitution or no? Okay. We are going to skip 6-3 because integration by parts is not a good. Guys, calm down. Just calm down. I don't know what, but y'all are making me a nervous wreck this morning. I don't know because y'all are so like, it makes me nervous. Okay. Is it the weather? Okay. No, I shouldn't say a nervous wreck. Not a nervous wreck, but it just makes me nervous. I get all nervy. Separation of variable, yeah. Separation. When I first started teaching, well, not variation, variables. When I first started teaching, I wrote separate on the board. And one of the English teachers that I was friends with then, her name was Miss Williams, and she came in and she says, Stacy. And I had spelled it Seperat. And she said, Stacy, there is a rat in the middle of separate. It's spelled Separat. A rat, not E rat. There's a right, yes. And I have never forgotten how I was so embarrassed because I felt like I was illiterate and teaching school. Whenever she came in and looked at my board, I was like, I am so sorry. I felt so. But anyway, I've always remembered how to spell it now. I can't spell. I can't. All right, let's recap. We're going back to solving differential equations. Found a good one. Solve that. Solve that for y. This is one from your homework like 4 or 5 nights ago. You're looking at it like you have no idea what to do. Find the general solution. I feel like we're gonna have. Why was this before? How did we do this without u substitution? What did we do when we did this? Antiderivative. That's all we did to solve it, right? But this one was easy because there's no y here. This is where we got into slope field and stuff too. We just did the derivative. We moved this dx, or this should be dt, I'm sorry, to this side, took the derivative, and we find that y equals, well, what's the antiderivative here? Sine of what? T cubed. Let's see. Right? Are y'all following me? Mm-hmm. So if you let u be t cubed, then du would be 3t squared dt. So we did that before. We didn't really talk about moving this dt over like that, but essentially that's what we're doing, because whenever you integrate, you have to have that dt over there, right? Or that dx or whatever it is. So what we're going to look at today is what happens if, because I did a lot of slope fields that would say like dy dx equals x times y, right? What happens if you have something like that? Dy dx equals, let's say, xy squared. How might I be able to solve that for y when there's x and y there? In other words, I can't just go up, I'll just do this, because you got two variables there. So any thoughts on what you might be able to do? Yeah, good guess, but no, it's not even that hard. I'll just tell you. We're going to separate the variables, hence the name of the lesson, separation of variables. It's really tricky here, right? Golly, geez. So I'm going to get all the y's on the side with dy, and then I'm going to put everything else over here with a dx. So watch what happens. Now I can't really separate them the way they are right now. I'm going to kind of get them to where they're separatable. So dy dx equals x squared y squared. Do you agree with that? I'm going to multiply both sides by dx. Of course, you don't have to show every one of these steps. I just want to show you why this happens and what happens. So now dy equals x squared y squared dx. Now I can move that y squared to the other side. How am I going to move that to the other side? Divide, right? So if I divide by y squared, really what I have is y negative 2 dy equals x squared dx. Are you guys okay there? Now can you solve it for y? Sure. I hope you can. Yes, we can. In fact, if we integrate both sides like this, what is the antiderivative of y to the negative 2? Negative y to the negative 1, right? And it equals, what's the antiderivative of x squared? 1/3 x cubed. And I'm going to give the plus c to the x side just because it's a constant. It doesn't matter which side you add it to. I'm going to keep it on the x side, okay? Now I could go through and solve this for y, but normally these are going to be an initial condition problem. So they'll say solve for y when, this one is when y equals 1 and x equals 1. So now what do? Plug it in and solve for c. Now you can solve for y first and then plug in, it doesn't matter, whatever you want to do. I prefer to plug in whenever, as early as I can. Negative 1, I'm just going to write it all out here so you see what's happening. 1 to the third plus c. So I have negative 1, 1/3 plus c. Subtract 1/3. Y'all with me so far? So I'm going back to this initial equation, and I'm going to say that negative y to the negative 1 equals 1/3 x cubed minus 4/3, but I'm still not done because it asked me to solve for y with that initial condition. So now what? Divide by negative. Change everybody's signs. I can do that. So y negative 1 equals negative 1/3 x cubed plus 4/3. Now what? You got to flip everything. You're exactly right. These technically have the same denominator. Think about it like this. I could add these together, right? I could say this is negative x cubed over 3 plus 4 over 3, which is negative x cubed plus 4 over 3. You can think about it as flipping both sides. You can think about it as raising both sides to the negative 1. You can think about it as a cross multiply kind of problem, however you see it best, but you got to get rid of that exponent there. Since there's just one fraction, I find it easier to just say, well, I'll just flip both sides. If that's hard for you to see, though, this is 1 over y. Yep, that's the answer. I could cross multiply. So 3 equals y times negative x cubed plus 4, and then divide. Any way I do it, I should come back to the same answer. Just however you see it best. That makes sense. That's a separation of variables, and that's all it is. But you'll have to use everything you know about integration in order to do it. Y'all want to do one more together? Let's do a hard one. This one was like fun. Oh. Is it really? The integration or the separation of variables? But You like the U stuff? Is it the U stuff you don't like? You like the more visual things like the areas under the curve and that kind of stuff? I'm sorry. You're going to be real annoyed before you get better, I'm sure, then. We're almost there. We're almost there. We just saved the best for last. It's hard for me because my brain starts going derivative, antiderivative, what am I doing, which one does what, and I start getting confuzzled with which. That's my biggest problem. But I've always done that though. I've always done that. All right, thoughts. Remember, get the y with the dy, get the x's with the dx. It's separation of variable, all the same variables on opposite sides. That's your goal. Then we can integrate. I think I'll start by multiplying by dx and just getting it over there. Now what's the problem? I could move that whole 4, or I could just move the square root of y. It doesn't matter. Just do the y. Henry said just do the y. Okay. So let's divide by square root of y. I'm gonna write it like this so you can see what's going on. I know. All right, so I end up with, and I'm gonna write this as y to the negative 1/2 instead of in the bottom like that, just because I know I'm fixing to integrate and I want to make it a little bit easier as I try to find the antiderivative. All right, so it equals 4 log x over x dx. No, I can do it. Never mind. I was okay. What now? Try integrate. Oh, I forgot to give y'all the initial condition. I mean, we don't need it yet, but it said y equals 1 when x equals e. All right, antiderivative of y to the negative 1/2. All right, let's add 1. That would be positive 1/2. So I'm going to flip it and put it in front. So I get 2 y to the 1/2. Is that what you said? I'm going to have to do a little U sub here. Unless you can see it without it. Okay. If u is log x, what is du? 1 over x. And I'm just going to pull this out front. Y'all see that? So I've got 4 times the integral of u du. Y'all tracking with me? Are you confused? Wait, are you sure? Where did you get lost? Where did I lose you? Well, I need to do the integral of log x over x. And I don't know the antiderivative of that. But I see that the derivative of log x is in the problem. It's 1 over x. So I did a U sub. All right, antiderivative of u. Adam, I change that back for you. Square root. Antiderivative of u. 1/2 Are you all okay there? You actually could at this point if you wanted to. Now remember, u is not u. U is actually, I gotta sub it back in. All right, okay. Sure. Now it said y is 1 when x is e. I need to solve it for c. It's a lot of variables. All right. So, right, square root of 1 is log of e squared plus c. 1, that's 1. So 1 equals 1 plus c. So c equals 0. Back to my equation to plug that in. Yep. So square root of y equals natural log of x squared plus 0. I don't need a plus 0, right? So y equals natural log of x to the 4th. Y to the 4th. Tell me what you think about separation of variables. You will definitely have an FRQ on a separation of variables. I have not seen a test that didn't, but here's the cool thing about it. It'll probably be one of those where you get so many points. Like when you get a point for recognizing that it's a differential equation. You get a point for getting the variables on different sides. You get a point for integrating just one side. You get all these points here and there whenever you have a separation of variables or an FRQ. So it's really cool because even if you don't get down to this very last thing, no, this would definitely be an FRQ. What do you think? Henry's so excited to do this work he can't always stand it. He's ready to get it. Contain yourself. Contain yourself. I did pick the hardest one. Do y'all want to do another one or are you good? All right, we'll do. I'm trying to decide about tomorrow if we're going to practice with